Thank you. Good evening, everyone. My name is Rita. I'll be your tutor for today.
Good evening.
Can you pause the recording, please? Okay, so today we'll be talking on SDLC and STLC, what SDLC entails and what STLC entails, as well as the difference between SDLC and STLC. If you guys could remember on the introduction, I did touch on SDLC, and I remember talking about the importance of SDLC. So I hope you guys jotted that down, because I'm not going to go into the why, but we'll be going deeper into the SDLC formats and structure. Please, can I ask everyone to be muted, and for the purpose of the recording, and if you have any question, you can take notes and jot down your questions. After the section, we'll be taking question and answer. We'll be going through question and answer session, and if not, you can also put it on the chat. My colleague is with me, Rexford, so he can also take any question on the chat. Okay, so SDLC, the acronym for SDLC. So you keep hearing SDLC, but the full meaning of SDLC is Software Development Lifecycle, which can also be classified as a software development process as well. So it is a framework that defines the tasks that performed at each step in the software development process. So the software development lifecycle is a structured process that is used by the software development team, and is used to design, develop, test, deploy, and as well as maintain software applications. So it's just a structured approach to creating software application. And it might interest you to know that it consists of multiple phases, each with its own set of activities as well as deliverables. So let's just go deeper into what the SDLC is. So the software development lifecycle is the cost-effective and time-efficient process that development team use to design and build high-quality software. It's also said the goal of SDLC is to minimize project risk through forward planning, so that software meets customer expectation during production and beyond. So like I said, it has different phases, and we'll be touching on all those phases as we go along. And each phase has a specific task and goals to ensure that the final product meets user needs and perform reliably or as expected. So this methodology outlines a series of steps that divide the software development process into tasks. So as we get into it deeper, you get hold of what I'm trying to say. You get an in-depth of what SDLC. So you can assign, you can complete, and you can as well measure. So each phase of the SDLC serves a specific purpose and contributes to the overall success of a software project. So I have this diagram here, which as you can see, is a life cycle of a chicken or a hen. It starts with the egg and then goes into a chick and then becomes an adult. So there's no, can you be muted, please? So there's no, let me see. So isn't, Okay. So as we all know, there's no way you can an egg can become an adult. It has to go through the process. It's a cycle. The same thing as human. If I'm to use the human analogy as well, from conception to pregnancy to delivery to um, baby, toddler. So is in phases. So you don't go from one stage and jump two stages before getting to no. So you have to go through the process. That's the same way. That's how SDLC is. It's a structure. You have to go systematically, one step after the other. As we go on, we'll get a clearer understanding of. Okay. Can you pause, please? Pause the recording. Development life cycle. Oh, thank you for that. Um, click on it, so it should come up. So these are the stages of the software development life cycle. We have the planning and analysis. We have the define requirements. We have design. And we have the development, testing, as well as the deployment. So these are the 6 stages of the software development lifecycle. Next slide, please. So we'll be taking them one at a time. Okay, so this diagram is just an illustration of how it goes. So you can see it is in circle, like as the name says, software development life cycle. So you go from the planning and analysis to define requirements, to design, to development, to testing, deployment, and maintenance. Next slide, please. So for the planning and analysis, so the phase involves gathering requirements from stakeholders and defining the project scope and creating the project. So this is the phase whereby the SDS system has to understand what the stakeholders want and or the clients, as the case may be, or the users, and to ensure that everyone have a clear understanding, the goals, the resources needed, and a well-detailed requirement and analysis and documentation. So for this, we'll be using a house building project analogy so that you guys will have a clearer understanding of what this is. So starting with you as it says planning and analysis. The first phase of the SDLC is the project planning stage, where you are gathering business requirements from your clients. I'm still on that slide, sorry. From your clients or stakeholders. So this phase is when you evaluate the feasibility of creating the product, revenue, potential, and the cost of production, the needs of the end users. So as it says in the name, the planning and the analysis. So this is where you could use a survey or an interview, or it depends on as the case may be, or a market research to gather your detailed requirements, which also can be as your analysis. You could use the scope, you could use the objectives and the deliverables to define this phase as well. So using a building analogy with planning and analysis, as we all know, when you are building a house, you draw a plan. And this is where you talk of the numbers of rooms and the type of house you want. Is it a bungalow? Is it a duplex? Is it a townhouse? Or the location as well as style. So this is the planning phase. This is where you kind of craft, you map out how you want it to be, or everything that is required. This is when you think about the timeline as well as the cost, the budget, the money required, things that you want to do. This is where you sit down and put every piece of information, everything that you think you would need. This is where you kind of structure it out, you outline it out. Which takes us to the next slide, which is you define the requirement. So for defining the requirements, on this phase, the development team will then define the requirement, bearing in mind all the information gathered. So as it says this phase is critical for converting the information gathered during the planning and analysis phase into clear requirements for the development team. So like I said, this bit is where the developer would then define the requirements by investigating the validity and the possibility of incorporating these requirements into the software system. So it says this process guides the development of several important documents. So a software requirement specification, which is SRS, a use case document, and a requirement traceability matrix document. As we go along, you will also get know the meaning of requirement traceability matrix. So it's what you use to document the progress or track the progress of the project. There are different ways, different methods of approaching of creating a requirement traceability matrix. I think depending on organizations, so the people use different method. You could use simple as Excel sheet to create your traceability matrix. So essentially, this is where you document every step of the progress of the project, and as well as mapping it with the requirement that you have. If it aligns with with the requirement that you are meant to kind of follow, the guide, the steps that you are meant to go. So it has to be in the same, it has to align with each other. I'll put it that way. So this phase, so say for instance, I want to use a house analogy on this phase. We will say this is where you decide the number of rooms, the style of the house, the materials to use, and the budget again. So say because in the planning phase, you could have a lot of things that you've added. And then in this defined requirement stage, you would then kind of map out, maybe in the planning phase, you've put, oh, I want more than 12 feet garden or 25 feet garden. And then, oh, my budget is 1 million. I want 12 rooms and your budget is 500,000. So by the time you are now coming to define the requirements, you will then streamline what needs to go in and what doesn't count and all that. So which takes us to this next phase, which is the design. The design phase is where you put pen to paper, so to speak. The original plan and vision are elaborated into a software design document that includes the system design, programming language, templates, platform to use, and application security measures. So this is also where you can flowchart how the software responds to user actions. In most cases, the design phase will include the development of a prototype model. As you can see, I've highlighted that bit. That's something you can take on your own, jot it down. You can do a research on that. And creating a pre-production version of the product can give the team the opportunity to visualize that the product will look like, what the product will look like, and hold on. Go back. It's not working. Go back, please. I'm still on the design. Design. Back. Okay, thank you. So this is where you so yeah, creating a pre-production version of the product can give the team the opportunity to visualize what the product will look like and make changes without having to go through the hassle of rewriting the code. So this bit, developer will then create a detailed software design specification, which will include an architectural design or data model, as it says in there, or the interface design. So this is the process where you kind of visualize how you want it to look like. And it so in this bit, the developers then all the components of the software will work seamlessly together. This is the bit where the developer will kind of know, or if say for instance on the analogy, you complete an architectural, you create a detailed blueprint for the house. So this blueprint will specify the layout, the dimensions, the materials to be used, and the structural details. So this phase is crucial for visualizing what the final product will look like, how it will function, and stuff like that. Next slide, please. Thank you, Rexford. So we have the development. The actual development phase is where the development team members divide the project into software modules and turn the software requirement into code that makes the product. So on this stage, the development stage in SDLC involves writing the actual code to create the software according to the design specifications. So an analogy of this can be called the construction phase. And like as it says the SDLC phase can take quite a lot of time and specialized document tools. So it's important to have a set timeline and a milestone. So the software developers understand the expectations, and you can then keep track of the progress in this particular stage, which is the development stage. So, and again, like as I said here, it says in some cases, the development stage can also merge with the testing stage, but not enough in all cases where certain tests are run to ensure there are no critical bugs. So developers write the actual code based on the design document. I must say this is the most hands-on phase, whereby the software is built by translations of design specifications into functional code. So like as I said, with the house thing, you lay the foundation, you erect the walls, you install the plumbing and the electrical systems, you complete the structural elements and interiors and things like that. So this is the phase that transform the plan into physical structure, you know, the phase whereby the detailed plans are transformed into a tangible product, so to speak. Yeah. Next slide, please. So we then have the testing phase, which is before getting the software product out, the door to the production environment. Is important to have your quality assurance team perform validation testing to make sure it is functioning properly and does what is meant to do. So the testing phase actually involves validating that the software function as intended. Behavioral, like if you click on say for instance you want to go to the next, you are clicking on a feature that is meant to take you to the next page, you are expecting it to do that. So this is all the process whereby you have to test that all those functionalities is working as expected. So you can say the testing process can also help hash out any major user experience issues and security issues. So in some cases, software testing can be done in a simulated environment. Other simpler tests can also be automated. So the types of testing to do in this phase can be, I think I also touched on some phases last time when I did the introduction of introduction into software testing. So these are some of the testing that can be done depending on the project. You don't do all the testing. Some are not all done by testers. And sometimes in some cases, you are not the only one that will perform all this testing. So we have like the performance testing can be done by a different set of testers. And then the functional tester, which is mostly us, we deal with because we work on user interface, which are the functional testing. So we kind of test the functionalities of the software. So we also have security testing, which are done by different types of testers. But you can also do it. I mean, you can train yourself in that field to become a security tester. And we also have the unit testing, the usability testing, as well as the acceptance testing. So this, like as I said, this phase mostly includes unit testing, which is checking the individual components, and then integration testing, ensuring all components work together. That is integration testing. You like the unit testing, you test the individual components. Like I think I touched on it last time as well, like the what is it called? Modules and I'm forgetting the other one now. So those are the ones you test them one by one. Then the integration testing, you then put them together and see if they will work together, if the units, if the components, if they are being brought together, if it will work effectively as expected. So that is integration testing. That's one easier way of understanding unit testing, because these are all interview questions. Can I also say that if you're going to be writing your ISTQB, this is what you need to understand. A deep understanding of your manual test will help you pass your ISTQB exam easily. So, like as I said, unit testing is testing the components, the units individually, while integration testing is testing them together, like bringing them together to test, ensuring the components work together. That's unit testing. By the time you add, why am I forgetting module and what's the other one? By the time you add them together, if it works as expected. And then you also have
the integration testing.
Yeah. Thank you. Then you also have the system testing, verifying the complete system. This is where you test the whole functionality of the whole system. And then you also have the user acceptance testing, which is you ensure that the software meets user requirement. Like as I said, there, say acceptance testing, application testing, or fit testing. So this is the phase whereby the software undergo rigorous testing to find any bugs, any defects before it's being delivered. So let me use, since we are using the house analogy, so I'm using this analogy so that you will have a clear understanding. If you remember, we started from planning, which is you writing down everything you need, and then you define the requirements as well as to development, and then to design, and now testing. So after construction, you want to ensure that everything is built correctly and safely. You thoroughly inspect this house before you move in. You kind of check if it meets quality construction at the plumbing and electrical installation working together, like in the case of hot water. You understand? This is like the integration testing now I'm talking about, because without electricity, even if you have water coming through your plumbing, you won't get hot water because there's no electricity, except in the case of maybe there's gas. So there has to be a link either via a gas or electricity. That's how you get hot water. So that's the integration bit. So when you move into this house, first thing you want to know is, do I have hot water? You see? And then does the house meet all the safety and building regulations, things like that. So you kind of inspect it before you move in. That is you testing the house before you move in. Is it okay? Oh, as I walk in, hope the walls will not fall. Are the windows firm? Is the door okay? Does the door open properly? I've seen a video whereby the builder built, I don't know if any of you have come across that video. The door to the toilet was put wrongly. So you can't go in because he put the door on the other side of the toilet. So those are some of the things, errors that can happen. Probably the carpenter or whoever did that didn't take note of that. So that's an error. That's already a bug. You can't use that toilet. So it has to be fixed. So which takes us to the next slide. I hope everyone is understanding this. That's why I'm using the house analogy. So moving on to deployment. During the deployment phase, your final product is delivered to your intended user. So in this process, in software development life cycle, you can either use automation. So you can automate this process and schedule your deployment depending on the type. For example, if you are deploying a feature update, you can do so with a small number of users, which is called canary release. And if you are creating a brand new software, you can learn more about the different stages of software release life cycle, which is the SRLC. But in software development, deployment involves installing the software in a production environment, whereby it will be useful for it will be used by the end users. So this phase actually sometimes might involve training the staffs, depend on the kind of project that it is, and to ensure smooth transition. You might also do a video, things like that, for them to watch. Because say, for instance, the project is like for a company, or say like an NHS healthcare system, something project. The user needs a guide. So sometimes you could do a video to illustrate how it can be used, or you could go in person to give them a training of how this can be used. So an analogy of this is also after the inspection is being done in the house, it's ready for you to move in. So you set up all your utilities, moving furniture around, ensuring that everything is in place for you to kind of have a start living your life comfortably. So this deployment phase can also involve configuration of the software for the end user, so or data migration. It can be any kind of project. So yeah, that's deployment. And then we move quickly to the next slide, which is the maintenance. And so for the maintenance phase is the final stage of the SDLC. If you are following the waterfall structure of the software development process, this will be the final stage. It says if you are following the waterfall structure of the software development process. However, the industry is moving towards a more agile software development approach, which is what we practice here in Blue Sky. And most organization out there uses Agile. We'll be touching more on those methodologies as we progress into the class. So software development approach where maintenance is only a stage for further improvement. And in the maintenance stage, users may find bugs and errors and that were missed in the early testing phase. So these bugs needs to be fixed for better user experience and retention. And yeah, so after deployment, the software enters a maintenance phase, whereby updates can be done and bug fixing, enhancements are made based on user feedback, because sometimes in this phase, you can then find out that, oh, maybe users will then say, oh, maybe it should have been this way, or maybe this feature should have been that way. So sometimes an update can be done in that process, and enhancements can be done. And based on the feedback you are getting, because if you have a lot of users giving you that feedback, then you have to work according to the feedback. That's agile for you. You have to take feedback on board. And sometimes it could also be new requirements. You might just want to enhance it. You just want to improve it, things like that. So this phase ensures that the software remains functional and up to date, and it is secure. So with the use of the analogy, I would say maybe after moving in, you regularly maintain your house, don't you? You kind of keep the house in good condition, whereby you are repairing if there's any leaks. I mean, you could sometimes just finish building a house and you find out that there's a leak. The reason why that leak might not have been um, noticed in the early stage was maybe because nobody was using it. So by the time you start using it, you could then experience a leak. So these are some of the things. And then it could be due to maybe a screw that is not tightened properly, or a burst or anything. So all these things are just normal. It's the same space in terms of software as well. So these things can happen in the a software development life cycle. So you can also be painting the walls after a year or two. You could be upgrading your fixtures in your kitchen. And over time, you might also want to expand the house, which is the enhancement we are talking about. You might say, oh, you know what? I have more space here. Maybe I should put a bar here. Maybe I should put this there. Maybe I should put that there. So that's just what it is. So in this maintenance stage, users may find bugs and errors that were missed in the early stages. So the SD phase can also restart for new features. You may want to add in your new release and update. So by reviewing software development through the lens of building a house, which I've just used, it makes it easier to understand the importance of each phase and how they can interconnect to produce a reliable functional product. So that is why I've used the house analogy. You see, it goes step after, that's from one stage to another. So that's the same way software development cycle is often involved iterative cycle of improvement, regular assessing and enhancing the software to better meet user needs and adapt to sometimes new requirements, like as I said. So you just have to adapt when there's a new requirement. You just have to find a way to work along with it. You have to adapt. You have to be ready to adapt. These are one of the soft skills I said you have to bring in adaptability. So you have to be ready to adapt. A project that is done, a new requirement could just come up and say, you know what, we need to put this requirement into, you should be ready to adapt to it. So that's software development life cycle. Next slide, please. So we have the learning objectives, which is the software development lifecycle we've talked about. We have the different models of the SDLC, the pros and the cons, the concepts in understanding testing. Next slide, please. So software development lifecycle, iterative and incremental development models. We have the waterfall, we have the V model. I'm going to be talking on them. Next slide, please. And software development lifecycle SDLC models, which is the waterfall linear model. We have the Kanban and the Scrum. We have only chosen these three to talk on. So which can be classified as methodologies as well. V model, sequential development model, iterative incremental development model, which is Agile. So we'll take waterfall. Next slide, please. So as you can see on the diagram on my own right, so it's sequential, as you can see. The requirements, the design, the development, the testing, the deployment, the maintenance. As the name says, software development life cycle, it goes round. You kind of find out that, oh, are we repeating? Are we repeating? Yeah, you might say that, yeah, because it's going around, it's a circle, but it's applied in different form and different process to it. So this model arranges all the phases sequentially with each new phase depending on the outcome of the previous. So without a planning, without a requirement, there will be no design. Without a design, there will be no development. So each phase relies on the previous phase. It provides structure to project management, but there is little room for changes. Once a phase is complete, take note of that, little room for changes. So once a phase is complete, so it's best for small or well-defined projects. So waterfall, what I'm trying to say here is, for a big project, an extensive project of up to 2 to 5 years, waterfall will not be ideal for such projects. So for a smaller project, waterfall will be okay to use because of the little room for changes. So that is why waterfall will not be advisable for a massive project. And so we have the requirement phase, we have the design phase, we have the development phase, we have the testing phase, we have the deployment, as well as the maintenance. So waterfall model is a linear and sequential approach to software development where each phase must be completed before the next begins. So basically, this model is structured and follows a top-down process. Like as I said, top-down, as you can see on the diagram, ensuring that each phase is fully finished and must be reviewed before you move on to the next stage. So once the requirement is done, it must be reviewed and say, okay, yes, we are good to go to the next stage. Until then, you can't go to the next stage. And the requirement phase is for you to gather all your specifications, as we said in SDLC. So you gather your documents, while the design is for creating your specification based on your requirements. And then you also have the deployment, which is the actual code that is built. And then the testing phase is the quality checks, the inspections, the validations, while the deployment is software is deployed to the production environment. And for the maintenance is after deployment, the software needs to be maintained, like as we said earlier, fixing of the bugs and etc. So we also have I also put there the pros and the cons. So phases that are processed and completed one at a time works well for smaller projects, like I said earlier, where requirements are well understood. For the cons, you complete a stage before moving to the next. So if something is wrong in the later stage, there's no chance to going back. This is an expensive model, because what I'm trying to say here is, in your cons, if something happens during testing, then you have to go back to requirement. Or you have to go back to deployment, then deployment have to go back to design, then design have to go back to requirement. So that is how it is. So which is expensive and time consuming. So that is for waterfall. But in a smaller project, like as I said, if the project is well understood, the chances of this error occurring are slim, and changes can be made depending on the kind of error. But for a big project, when such error occurs, it's kind of expensive to fix because of the process. Next slide, please. Thank you, Rashford. So we have the VU model, sequential development model, also known as the verification and validation model. Please take note of those two things. I think I touched on it last time as well. Verification and validation. The VU model guides where testing needs to begin as early as possible in the SDLC lifecycle. Testing is not only an execution-based activity, it also involves various activities that must be covered before the end of the coding phase. So the V model, which can also be classified as either verification and validation model, is an extension of waterfall model. So it is characterized as a corresponding testing phase for each development stage. And this model often ensures that each development activity is directly linked to a testing activity. So a As you can see, we have the verification phase. We also have the validation phase. If you also look at the other diagram, you have the requirement gathering. You have, on the other hand, where it says validation phase, you have the acceptance testing. And then you then have the system analysis as well as system testing. So for the verification phase, it says business and / user requirement. Detailed requirement of the software system to be developed are gathered from clients. So checking what kind of house you want. Again, like as I said, checking what you need. That is you gathering your requirements. And then the validation says acceptance testing involves testing the products to user environment. Testing planning and planning how you will verify the house meets your needs once it is built. Then you also have software application design, how will the system work and interact, functionality or features that goes into the system. So this is you checking the entire system functionality and the communication of the system under development with external systems, with the plumbing and the heating, or with the plumbing and the electricity, bring you hot water, or that's for integration. Now this is you checking the whole house. Is everything working as expected? Is the electricity properly connected? Is the stairs built properly? Things like that. Does the house meet construction quality? Then architectural high-level design of software, high-level technical details, coexistence of components that make up the system, which is the integration testing. Like as I said, does the hot water and the this thing what is it called? Sorry, hot water and the electricity and the plumbing, does it produce hot water? Things like that, because that's the end result. That's what you want to get. So integration tests are performed to test the coexistence and communication of internal modules within this system. Then you have the module detail system as well as the unit testing. Next slide, please. So here we then have the view model sequential development, which is what is verification. Verification involves evaluating a work product, component, or system to determine if it meets the development requirement set. The main focus is the deliverable product built according to specification and standards. So verification ensures that the product is being built correctly according to the design specification and requirement. Like, are we building the product right? That is you verifying. Like as I said, is the deliverable product built according to the specification and standard, which is, are we following the requirement? Then, why validation says it's a process concerned with evaluating a work product, a component or system to determine if it meets the user requirement and needs. So the main focus here is the deliverable product fulfill, sorry, that was typo error. As if fulfill its purpose and provide a solution to the customer, to the customer's problem. So I'll give you for that validation, like, this is where you say, are we building the right product? You know, for verification, I said, are we building the product right? If you notice, there is six words interchangeably. So why validation says, are we building the right product? So because validation ensures that the product meets the need and expectation of the user. Validation is for the user. You are validating it that, oh, will the user be able to use it? Is this what the user wants? Are we building the right product for the user? Will the user like this product the way the user wants it to be, or the client or the stakeholder? Why verification is you now questioning, are we building it right? Are we following the right process? Does the requirement say we should build it the way we are building it right? I hope it's clear. Because it says, now that we understand the importance of the testing process, let's learn about one of the software models that help improve cost and time efficiency, enhancing coordination between a team through defining proper roles for employees and minimize risk potential when deploying the project. So some of the pros and cons of this is View model is highly structured, which makes it easy to understand and manage because each phase has specific deliverables and a review process. So that's the good thing with it. Once you finish it, it will be reviewed. So once your test lead or your test manager said, yeah, it's good. What you have done on this stage is good. You are good to go. That means normally with that, there shouldn't be any error, but sometimes error can still occur. So one of the advantages is testing early in the life cycle, thereby enhancing the probability of building an error-free and good quality product. You know, it focuses on verification and validation to ensure that the final product meets design specification and user requirements. Then for the major drawbacks, that's for the disadvantage. View model, any changes happen in midway, then the test document along with requirement document must be updated, like as I said, because if there's any problem during testing, then the design has to be checked, as well as the development, as well as the requirement. So it will then go back in step. There must have been an error from requirement. That is why there's a bug. So that's the problem with View model. And it involves limited user involvement, unlike Agile. User involvement is primarily mostly at the early stage, which is during requirement, or probably when everything is done at the end, whereby it can lead to the product not fully meeting user needs, So that's the difference, the disadvantage with View model, because the user only have the opportunity, or the communication is only there from the beginning and at the end, unlike Agile. So we'll go into Agile now, and then you'll see the difference. Next slide, please, Rexford. Thank you so much. So we have the iterative and increment development model, which is the Agile. So with this model, the team begins development with a small set of requirements and iteratively enhances versions until the software is ready for production. So this is what we practice here in Blue Sky. It's easy to manage risk, but repeated cycles could lead to scope change and underestimation of resources. So this model is best for projects that require high flexibility in their requirements and have the resource to handle multiple iterations. So Agile is an iterative and flexible approach to software development, because collaboration and adaptability is of high priority for delivering a working software. And incremental cycles are called sprint. So like as we can see here, if you notice the diagram on my left, you have the planning, testing, building, designing. As you can see, it's going in circle. You see this? So that iteration 1 is classified as sprint 1. And then you go to sprint 2, the same process is being carried out in sprint 2. The same process is being carried out in sprint 3. So you keep repeating, you keep going round in circle, the same process that was done in sprint. So this is you bringing it out in small chunks, because in sprint, you will not bring everything out. Maybe say, for instance, some organization do sprint 2, why some 4 weeks, depending on the organization. Here in Blue Sky, we do sprint for 2 weeks. So in that 2 weeks, you will then have your PBIs that has been committed into the sprint, while estimation is being done. So all those cycle, when you test it, all those process, you will repeat it again in the next sprint, And individuals and interactions in agile development, self-organization and motivations are important, as are interactions like co-locations and peer programming. Demo working software is considered the best means of communication. What that means is when like if you remember in vModel, is only at the beginning and at the end that you have the user is involved. In this in Agile, user can be involved. When a particular feature is completed in that sprint, it can be demoed to the user, to the stakeholder, to the client. So they would then see, oh, okay, oh, this is what you've done. This is nice. Okay, this is exactly how I want it. Or no, this is not exactly how I want it. So requirement can easily be changed in that process because you have demoed it and it's looking exactly what the client wants, or if it's not exactly what the client wants, then requirement can be updated in that process. So that's where the demo comes in. And as the requirement cannot be gathered completely in the beginning of the project, so sometimes you don't get everything in the beginning. It depends on the kind of project. So due to the various factors, continuous customer iteration is very important to get proper product requirement, and agile development is focused on quick responses to change and continuous development. Next slide, please. Because so this is like the sprint I was saying. You have definition of ready. You then have your backlog, you have your integration, your test, your deployment, and delivery, and the definition of done. So those are the things you should know. Definition of ready and the definition of done. Definition of ready is the beginning of sprint, whereby everything is in place. Your PBIs is ready, your estimation is done, and then by the time you get to definition of done, that means you have tested everything and everything is as it should be, is as expected. So agile kinds of promote customer satisfaction. It focuses on delivering working software frequently, ensuring that customer feedback is also incorporated early, because once you demo it, any feedback that comes will go back into the next sprint. So whatever the outcome is, you have to bring it into the next sprint. Okay, this is what we are meant to do based on the feedback that we got. And collaborative approach, agile encourages close collaboration between cross-functional teams, including the developers. You have to be in good terms with your developers. There will be times that we look like heated argument based on, oh, it's meant to be like this. It is normal, but then nothing personal, because you have to be in good terms with your developers and as well as your stakeholders. Next slide, please. Are you there? So which takes us to STLC. STLC is a software testing lifecycle. That's the full meaning of STLC. It's a sequence of specific actions performed during testing process to ensure that the software quality objectives are met. So STLC includes both verification and validation, because STLC is a subset of SDLC. If you remember, we have the testing phase in SDLC. So now we are now talking about the software testing life cycle on ISO. The testing has its own life cycle as well. So it's a series of phases performed during the testing process to ensure the quality and the reliability of a software application. So software testing life cycle ensures that testing is conducted in a systematic and organized manner. So this process helps us to identify defects early in the software development life cycle, and ultimately it improves the quality of the software product. So and testers do play a crucial role in ensuring the quality and reliability of the software being developed. So that takes us to the next slide, please, Rexford. So what is the role of a QA in SDLC? Even with the most talented, highly skilled team of developers, mistakes can still happen as a result of human nature. If you remember, I think you did error, defect, and failure. I think I had the tutor taking you guys on that. So yeah, errors can happen, mistakes can happen. So the role of software testing lifecycle is to identify any mistakes that have been made and find solutions for them, helping to maintain the quality of every piece of software produced and ensuring that the software requirements are met. If you move to the next slide, please. So we quickly take the next slide, please, Rexford. The phases in SDLC. So we have 6 phases. As you can see, it's in circle. So this diagram is just to illustrate how it goes from the requirement analysis phase to the step testing planning to the testing design to environment setup to test execution and test life cycle. Next slide, please. So we quickly touch on them. The requirement analysis is the first step of the software testing lifecycle. In this phase, quality assurance team understands the requirement, like what is to be tested. So this phase involves understanding and analyzing the requirement of the software to determine the scope of testing. So as a tester, you should participate in the requirement analysis by reviewing and understanding the software requirement from a testing perspective. So you just have to think out of the box in this whenever you are in this phase as a tester. You have to collaborate with the stakeholders to ensure that the requirements are clear to you and they are testable as well as they are complete as a tester. That's why I said you have to look at it from a testing perspective. You have to understand it from a testing perspective. So if anything is missing or not understandable, then the quality assurance team meets the stakeholders to better understand the detailed knowledge of requirements. An analogy of that is, say, for instance, you are preparing a food for a special event. Before you start cooking, you carefully analyze the dietary or the preference or the restrictions, or as well as any expectations of your guests. So that's basically you understanding and analyzing the software requirement to determine the scope of testing and establish a testing approach. Next slide, please. So activities in requirement analysis includes, I've kind of put all the explanation into this slide, reviewing the software requirement documents and other related documents, interviewing the stakeholders to gather any additional information that is required as a tester, and you kind of identified any ambiguities or inconsistencies in the requirements. So as a tester, any missing or we must identify any missing or any incomplete requirement. This is why I say you have to think out of the box as well. You have to bring your A game in here. This is where you ask questions. You identify any potential risks. You have to think ahead, issues that or any issues that may also impact the testing process. You identify the testing objectives as well as the priorities. You review and analyze the software requirements, and creating a traceability matrix to map the requirement to test cases at the end of the stage. We also help you acquire a full test coverage. The testing team should have a clear understanding of the software requirement and should have identified any potential issues that may impact the testing process. Next slide, please. So the deliverables of requirement analysis for the requirement traceability matrix, the document maps, which is RTM. Take that down. You can jot that down, RTM. This document maps and trace the requirement proposed by the clients with test cases to ensure that every requirement has an associated set of test cases against it. I think I've explained this earlier. Using your traceability matrix will help you have a clear and depth understanding of the project, because you having your requirement in your traceability matrix as well as your test cases will help you to keep track of the progress of your testing. This will also ensure that you've covered everything that you're meant to test as a tester. So automation feasibility can also be conducted if applicable. This report will be produced as a result of analyzing the project, working out what screens have components that can have automation tests. Because with this is where you also need to have your screenshots and things like that, and inside your traceability matrix, and the complexity of writing the automation test, whether the test cases handle large amounts of test data, among other factors. Next slide, please, which should be the testing planning. So this testing planning is the most efficient phase of the software testing lifecycle, where all test plans are defined. And in this phase, manager of the testing team calculates the estimated effort, like we did in the demo. I don't know if you've done that in your sprint. You will do estimation. And then the cost for the testing work. This phase gets started once the requirement gathering phase is completed. So it involves creating a test plan, and then that test plan will help you outline the testing strategy as well as the objectives. I think I gave you guys, or not an assignment, but I did ask that it would be good for you guys to do like a research on creating a test plan, because as a tester, you should know how to create a test plan. And there'll be more on test plan, on how to create a test plan. I think not the next class, the class after that. So yeah, whereby your test plan should include your scope, your resources, your schedules, and your testing activities. So testers contribute to the development of the test plan by identifying the testing objectives and defining the strategies, estimating efforts, and determining resource requirements. So all this is what you will have in your test plan as a tester. So you should be able to create one, because if you go to an organization, any project, a test plan is required, because that's what we give you. That's what we go as your guide, as your map. So that is what you will use as your guide for that project. And in a situation whereby you are no longer there, somebody else should be able to pick up the test plan and follow suit from where you stop. That's the essence of a test plan. It gives us testers, it serves as a guide for testers on any project that you are working on. Next slide, please. So the activities in test planning, identifying the testing objectives, like I said earlier, and the scope, developing a test strategy. This is you selecting the testing methods and the techniques that will be required for the projects, and then identifying the testing environment and the resources that you need. So all this will have to be in your test plan. you identify the test cases that will be executed, and if any test data is also required, the estimating time and cost required for the testing. And this is where you also identify your test deliverables and your milestones. And this test plan also help prioritize testing activities based on risk and criticality. That's the essence of test plan as well. Is assigning roles and responsibilities to the testing teams. If you have more than one tester, if you have other testers that are covering other kind of testing, you kind of have to have it in your test plan, what they will be doing. You assign the roles and the responsibility to them. So like I said, it's a guide for the testing team. You review and approve the test plan. It has to be reviewed. Everyone has to be, it has to be generally accepted by all the testing team after you have created a test plan. So at the end of this stage, the testing team should have a detailed plan for the testing activities that will be performed. So another analogy of this is you creating a menu plan for the meal. I'm using this analogy so that it will help you understand it. So you develop a detailed plan that outlines the courses of the meal, the ingredients for the meal, the cooking methods, and the way, the presentation, the way you want it for each dish. This is you creating that. So that is what your test plan is. So it ensures that the meal will meet the expectation of your guests and to be served on time. That is exactly what test plan is. So this will help to ensure that the testing process is well organized. You know, if you have all these menus, all these ingredients, then you will be organized. The same phase. If you have all this, if you have everything in your test plan, you will definitely meet the right time for you to deliver your software application. So that's it's just the same process. That's just what it is. That's what test plan does. It is well organized, and the testing team is able to deliver high quality results via a test plan. Next slide, please. So the deliverables of test planning, a test plan document. ISTQB defines the test plan as: test plan is a document describing the scope, approach, resources, schedules, and of intended test activities. Test effort estimation document. This document will include the estimation of how long it will take to complete the testing task. So all these will have to be in your test plan. So that's your deliverables. Next slide, please. Let me see, what's the time? Okay, times. Okay, I'll be fast. Next slide, please, Restful. So we have the test case document phase, which gets started once the testing plan phase is completed in the phase testing team. Note down the detailed test cases. The testing team also prepares the required test data for the testing. And then when the test cases are prepared, then they are reviewed by the quality assurance team. So the test cases are developed based on the requirements and the test scenarios and the test cases that has been outlined, the steps to be executed, the expected and any preconditions. So that's what it is. Next slide, please. So next slide, please. So it says activities in test case development identify test cases that will be developed. So testers create detailed test cases based on requirements and scenarios. So you have to design your test case. Like as I said, you don't say write test case, you design it. It makes you more professional to cover various aspects of the software, you know. When you design your test case, you will have the opportunity to cover all various types of the software, the functions, the functions and the non-functional edge cases. You know, this also helps we testers to have a comprehensive and usable, easy way to understand the test cases by designing your test case based on your requirement. So writing test cases that are clear and concise and easy to understand, creating test data and test scenarios that will be used in the test cases. So reviewing and validating the test cases, updating your requirement traceability matrix to map requirements test cases. Like as I said, this traceability matrix. So when you've completed your test case, you update it on your traceability matrix. So at the end of this stage, the testing team should have a set of comprehensive and accurate test cases that provide adequate coverage of the software or application. Next slide, please. So the deliverables of test case development, like as we said, test cases, this is a set of actions that test a particular piece of functionality of the software project. You'll be taught on how to write test cases using the BDD formats, and then test data, the input is given to a software program during the execution of the test cases. It depends. Not in all cases do you get test data. Sometimes you might make up your own test data. In the case of maybe you are doing login, you can just create or use temporary emails and password, and as well as doing a registration, for instance. You can create your own test data. And then we also have test automation scripts. These are scripts created by automation engineers with the idea of them being run frequently to reduce the reliance on manual testing. So that's automation. So automation is quicker, put it that way. Like as I said, it reduces the manual testing effort compared to when you are using manual. So that's automation. Next slide, please. So which moves us to the next slide, which is the test environment setup. For this slide, it says it's a vital part of the STLC. Basically, the test environment decides the condition on which software is tested. So this is independent activity and can be started along with test case development. In this process, the testing team is not involved. Either the developer or the customer creates the testing environment. So a suitable testing environment is set up to replicate the production environment whereby the software will be deployed. So to wherever they want the software to be deployed to. So this includes something like hardware, software, network configuration, and other necessary components. So next slide, please. So testers ensure that the test environment accurately reflects the production environment so as to facilitate accurate testing. So activities in environment setup, also analyzing the requirement and preparing the list of required hardware and software to set up the test environment, like as I said earlier. So setting up the test environment, executing a smoke test on the test environment to validate the readiness and the stability of the test environment. So all this you get to understand: smoke tests, sanity tests. These are mostly done pre-production phases. So deliverables of test environment setup. The test environment is ready for the test execution phase and smoke test results. So a quick analogy of this would be you say, for instance, you are cooking, you have your ingredients, you have your cooking environment, everything is set. So that's just what it is. So similarly, your test environment is just set up to replicate the conditions in which the software will operate. That's just basically what this environment setup is. Next slide, please. Next slide. So the next slide is test execution. After the test case development and test environment setup, test execution phase gets started. So in this phase, testing teams start executing test cases based on prepared test cases in the earlier step. So this phase execution takes place in testing environment according to the test plan that you've designed, that you've created. So the software is systematically tested to identify defects or bugs. So after you've created your test cases, you then go ahead and execute it. Next slide, please. So Activities in test execution includes the test case and scripts created in the test design stage are run against the software application to identify any defects or issues. Like as I said, you systematically perform functional or integration system or regression testing to identify any defect, to validate that the software functionality is working as expected. So any issues you discover, this is when you will find a bug. Then you will then raise a bug. You will collaborate with the developer. If there are some bugs that you don't need to, you can just have a triage meeting. A triage meeting means you meeting with your developer and maybe your BA and say, you know what, the requirement is saying this, and this is what I found out. Sometimes it might not be a bug. It's just maybe just require an update. I was running a test case the other day, and the BA skipped the part where they should have put a phone number is required. But during my steps, I did added that to my steps. So I went back and I let the BA know you are meant to update that. So like in that case, you are not raising a bug for that. The only thing is not in the requirement. So it has to be updated. And you as a tester, since that field is mandatory, you shouldn't skip it. You have to go ahead and test that field. So in such case, you have like a triage meeting, So defect logging as well, any defect issues that are found during tests, I've talked on that. You can use a defect tracking system along with details such as severity. Yeah, we'll also be doing defects later on. So there are different kind of defects. Like as I said, you have the one that is of a showstopper. You have the one that is cosmetics. I was on a site the other day. I can't remember now which site. They had the spelling wrong. So like that, it's cosmetic bug. It's not a showstopper. It doesn't stop me from navigating to the next page. It doesn't stop me from clicking on one feature or functionality and not getting what I expecting. So that is like a cosmetic bug that can be fixed. It's not a showstopper. So if you are going to be rating that, it's of a low priority. So you also have the test data preparation. It's prepared and loaded into the system for test execution. You also have the environment setup, the necessary hardware, software, network configuration, and all the things. Then you have your results. The test results execution are analyzed to determine the software performance and identify any defects or issues. So this is where we know that the software is being built properly, it's being built correctly. Because any defect you find, if it's a showstopper, then that means this is not what we are looking for. So this is where you kind of analyze your actual and your expected results. I talked on this, I think. If it's actual, that's not what you want. You want expected. So you are expecting that when I click on hamburger, I should get hamburger, not getting Big Mac. Big Mac is the actual result, but expected result is for me to get a hamburger. So that's the difference. Please, I'm using all these analogies so that you will have a clear understanding. In another phase, if I'm to use the cooking analogy I've been using, you follow the recipe carefully. You monitor the cooking process and you keep checking for any issues when you are cooking. You want to know, oh, is it burning? You keep stirring. You don't want it to get burnt. Or does it have enough salt? Is it coming out as expected? Is the meat cooked properly? So these are just what it is. You are testing. You are testing to see you want an effective result. If the food is bad, you won't be able to eat it. That's a bug. So it's useless. And there are some bugs in the case of food cannot be fixed. So, but if in terms of software, it can be fixed. That's the good thing. And most times it's not being fixed by the testers. So then you have your test reports, which document and report all the all the reports that is required, for your bugs and things like that for the relevant stakeholders. So deliverables of test execution report on any defect that have been raised during the test execution phase, overall summary of test cases, results. Next slide, please. So we have test closure. So test closure is the final stage of the software testing lifecycle, where all testing related activities are completed and documented. So the main object of the test closure stage is to ensure that all testing related activities have been completed and that the software is ready for release. So once testing is complete, a test closure report is prepared, summarizing the testing activities, the test result, the defect found and fixed, and any recommendations for future testing. This is like you serving a meal. After serving a meal, you are then gathering the feedback from your guests, your opinion. What do you think? Is the food nice? That's when you see some people, when they go to party, when they like the food, they'll start asking, who is the caterer? Can I have a number? So this is a good feedback. So that's just what this test closure report does. So, and he also said at the end of the test closure stage, the testing team should have a clear understanding of the software quality and reliability, and any defects or issues that were identified during testing should have been resolved. Yes, during testing, any of these defects found should be resolved. And the test closure stage also includes documenting the testing process and any lessons learned. So like, as I said, the feedback you get and what happened during the project life cycle. Were we too slow? Were we supposed to, like in terms of risk mitigations and things like that, was there any potential risk that were identified? Okay, in the next project, we should make sure such thing, you try and avert things like that. All these test closure reports will be documented in there. And where testing related activities are completed and documented, the main activities that take place during the test closure stage includes, next slide, please. Test closure report, test summary report. The report is created that summarizes the overall testing process, including the number of test cases executed, number of defect found. That is what should be in your report. And overall pass or fail tests that you've carried out. And then you should have your defect tracking on it as well, identified during testing that you've tracked and managed until they are resolved. Then the testing environment cleanup and all test data and test artifacts are archived. And then a report is created that documents all the testing related activities that took place, including the testing objective scopes, schedules, and resources that were used. So knowledge about the software testing process is shared with the rest, feedback, and improvement. So feedback from the testing process is collected and used to improve. So all these are what should be in your closure report, as we can see. So you have the test matrix, which are quantitative measurements used to assess various aspects of software testing process and outcomes. So essentially, it provides valuable insight into the, say, effectiveness and efficiency and quality of testing activities. So basically, it helps provide valuable insight into testing process, helping the teams to identify areas for any improvements and ensuring the quality of the software products. That's what the test matrix does. Next slide, please. I think that should be it. So we have the SDLC versus SDLC. So the which I would also say you can also do your research on this, the difference between SDLC and SDLC. For the sake of our time, I'll just quickly go through it. SDLC is related to software testing, while SDLC primarily concerned with software development. And SDLC, we have fewer people, while SDLC, you have more people involved in terms of developers and all that. So SDLC is basically for the testing team, while the SDLC encompasses of the development life cycle, includes everyone in the project. And SDLC is concerned with both the development and testing process, but it's primarily concerned with the testing process. While SDLC development lifecycle assures that, supposed to be ensured that we deliver high quality software which is as per client's need. And in SDLC, QA team analyze all the requirements from the requirement document and create a system test plan. While in SDLC, the business analysts gather all the project-related requirements from a stakeholder. I hope that is giving some of us a breather that in the SDLC, is the business analyst that gathers the project's requirement, but that doesn't stop you, the tester, from understanding the requirement. So basically, in summary, SDLC encompasses the entire software development process. And this includes requirements, as we've talked, gathering, designing, excuse me, development, testing, excuse me, deployment, and maintenance. And why SDLC specifically focuses on the testing phases within the SDLC. Like as I said, SDLC is a subset of SDLC, and outlining the process and activities involved in ensuring that the quality and the reliability of a software product is carried out. Which brings us to the next slide. I think that's done. So this is just a diagram telling you SDLC and STLC. This is just for you to know what it encompasses. Like if you can see on the STLC, it's all testing, system testing, integration testing, unit testing. While on the SDLC, you have the requirement analysis, high-level design, low-level design, which we've talked on. And next slide, please. Thank you. And we'll be touching on defects, which is supposed to be part of this, but I thought it would be too much. So we'll be doing that in the next class. We'll talk about defects. I wouldn't want you guys to miss that. That would be a good and interesting one for you to know, because that is what we primarily do. Like, as I said, QAs, we are meant to find bugs, defects, as the case may be. So yeah, thank you so much. The next slide is question and answer. And Rexford is on call to take our question. I'm also here. And yeah, thank you. If you want to pause the recording and start all over again for the question and answer, I don't know, or if you want to take it in one go.
Rita, do you want me to go for it or?
Yes, please. Okay. Olat is also here. He can chip in. He's one of your mentors. Yeah.
Oh yeah, once Olat is online, let him go for it.
Yeah, on recording. Rexford, please.
No, let Mr. Olat go. Mr. Olat, good evening. Oh, he's not there. Okay, cool. So just like Rita explained, we have the software development lifecycle and we have the software testing lifecycle, and each lifecycle has got a stage. And when it comes to requirement analysis, when it comes to the business analyst putting in requirement, gathering requirement, that is when the QA can come in and, you know, start with requirement analysis. So during that stage, once the business analyst is, you know, populating the acceptance criteria, they are populating the requirement. There's something called shift left testing. So, I mean, during the course of the internship, you guys will get to understand it. You guys will put it into practice. You get a better understanding. So during that time, you will be reviewing this requirement or acceptance criteria to find out or to check if there are any errors in the requirement the business analyst is writing, or if there are gaps. So I'll give you an example. Let's say most of the time we usually use login, for example. So let's say business analyst is writing requirements or acceptance criteria for login, all right? And in the requirement, they state that when a user needs to enter their username, a user has to enter their password, and then a user have to log in. With these steps, you can notice that the business analysts have missed the step. what would the user do to log in? Does the user have to click on the login button? Does the user have to press the, does the user have to, what does the user need to do before they log in? There's a gap in there. So you, the QA, these are some of the questions you need to ask. These are some of the questions, these are some of the things you have to look out for when a business analyst is writing the requirement or acceptance criteria to find out if there are errors or if there are gaps in the requirements that are writing, or if it's too ambiguous. Sometimes business analysts also do write requirements or acceptance criteria that are ambiguous, things that cannot be achieved, things that cannot be developed. And with experience, you'll get to know these things and you get to ask questions and, pinpoint these things.
Okay. Thank you very much.
Okay, my question. Hello.
Yep.
Yeah. My question is, who in the team of this software development project, who comes up with software requirement specification, the SRS?
Okay, that's a good one. So software, did you say software requirement? Yeah. Specifications. Yeah. So software requirement specifications are defined by the business. In every organization, when you're in an organization, you are working for the company. So you are working for the organization, and these organizations have their needs. They have what they want. And that is when the business analyst will come in, because you, for instance, a business can have like an idea. Okay, so we want to, let's say Lloyds Bank, for instance, can have an idea that they want to develop an app whereby they want their users to be able to transfer money or to be able, like an online banking app, but they don't know, they have the idea that this is what they want to do. All right, they have a scope. For instance, they want people from UK, they want people from Germany, they want people from other European countries to be able to use this app. This is what we want to do, but they don't have the, okay, to do this, what do we have to do? What do we have to implement? Will this thing that will implement help the business? How is it going to benefit the business? Are there, what options can we put together? So the business has an idea. They know what they want to do, okay, what they want to put in place. But they will need someone to analyze these ideas, these decisions they want to take. They want someone to analyze it, someone to tell them how to implement it, and if it's going to benefit the business or not. And that is when the business analyst will come in, because that is what their expertise, that's their area of expertise. That's what they are good at. They'll analyze, okay, so this is what this business wants to do. Let's go on to the market. Is Monzo doing the same thing? Is HSB doing the same thing? Is Barclays doing the same thing? They will compare the market. Okay, if we do this, it's gonna help. If you do that, it's gonna help. Okay, this bank is using this application, this bank. So it's the business and the business analyst, they will put together this document that the developers are going to develop, or the development team is going to develop. And sometimes it's not just the business analyst, depending on the project you are working on. If it's a HR project, you might get, and there's also a PO. I forgot to mention that there's a product owner who also, and this product owner can be an internal employee, someone who is within the company, depending on the how do you call it, the department. So for instance, in my organization at the moment, we are working on an HR system, and the product owner in charge of the project is the HR manager. So she is the one defining the criteria. She's the one defining the SR is the requirement that we need to be able to develop this thing and, to put in place. Does it answer your question?
Yeah, so my little confusion in all of that is I know the BAs come up with the business, they come up with the customer requirement specification or user requirement specification or yeah, just stuff like that. Then this one I'm talking about is the software requirement specification. Like if you look at the V model, you have the verification and the validation side. So on that verification side, you have the user requirement specification, and then you also have the software requirement specification.
Yeah, I can quickly elaborate more.
Yeah, go ahead, please.
For the software requirement specification is more of like a document, a subset document from the requirement. So this is between the developer, the stakeholders, and the testers. So this is a bit different from your test plan, because this is the objectives and the aims of the software, the details of where the software will and will not do. So this is more or less like a mini or a subset of the test plan, because your test plan also covers your objectives, your scope, the schedules, the people that will be working on it, which is limited to the testing team. That's for the testing team. But this is now for the testers, as well as the developers, as well as the stakeholders, which can either also be your users or your clients. So it's a contract, I'll say, between the projects, stakeholders, and the developers. So it outlines any necessary requirements that the software must fulfill to satisfy the needs and behavioral, as in the expectation of what the stakeholders are expecting, what is expected of that software when it is completed. So it kind of encompasses the introduction, the overall description of everything that will be done, the specific requirements. So it's a subset of the requirement, but this time with the developer and the stakeholders and as well as the tester. So that's what we call software requirement specification. I mean, it's kind of the thing is, each organization have different things that they call all these things, to be honest. In some places where they might have SRS, they might not have a test plan, because it kind of is, like, as I said, it's a subset, because you kind of have the only thing is it doesn't cover everything. But you as a tester, you must have a test plan, which is compulsory. So, I mean, SRS might not be compulsory in most of the projects, but sometimes depending on the kind of projects that you are also working on, that's what SRC might be required. So that's just what it is basically.
Rita, can I chip in as well? So
yeah, sure, go ahead.
Yeah, at the moment, with the project I'm working on, we don't have an SRS. Everything is defined in the requirements. So it's stating the objectives, of the project, it's stating the environment, it's stating its audience, and it's stating hardly would, every organization and the way they work, every organization works differently, but most of the time, the SRS is defining the business requirements. So it depends, really. It depends.
Okay, thank you.
Yeah.
Any other question? Otherwise, we might have to start throwing our questions so that we leave. It's exactly 11 o'clock. We just throw a few questions. Rexford, you can go ahead with that.
Sorry, can I say something before we proceed?
Yeah, go for it.
All right, thank you, Rita, for these lectures. What I wanted to suggest is probably in subsequent classes, is it possible you break them into sections where questions will come at the end of every section you broke it into? Because this seems to be like a very long section, and at the end, I can assure you, I don't know. I'm just saying some persons might be lost already from where you started up until
You,
this. Yeah.
you can't be lost. This topic I've only taken, except you want to blame me for breaking it down, because I could have gone high level, but I've chosen to break it down so that everybody will understand. That's the essence of it, making it look long. Because don't forget, the only topic I covered was SDLC and STLC. If you go back to the slide, even my introduction, I think I had more different topics that I touched on. So this one is just one topic, which is SDLC and STLC, and just letting you know the difference, because as a tester, this is what you have to practice. So, and in this SDLC and STLC, I'm supposed to touch the defect. I didn't even touch the defect now. That's why if you notice at the end, I said I will put it in the next class. So if we take questions in between, then we will not achieve our goal. That's also another thing. If you remember the last class, we were interrupted by somebody asking question. I think it was real fraud. It's not here. Yeah. So things like that will not progress. So that's why I said, if you have questions, jot it down. Like, as I said, if any time you attend any meeting, not even a class now, any meeting at all on Blue Sky, always be with your pen and paper. You will come, that's when you will come across somebody will just talk about an interview question. If you don't take it down, that's it. You might even come back and ask the person, what did you say? He might not be able to explain it the way he previously explained it. So this is just a best practice for you to get there. Because the truth is, this work experience, I call it for you people, or work placement, is 3 years compressed into 3 months. So you have to come with your A game. When you are in class, you have to stay focused. You have to be attentive. Trust me. Like, as I said, that's why I keep telling you guys, do your research. Come with your questions. If you are ahead of the class, it will even help you. And like I also said, this is where you will get all the necessary information to write your ISTQB exam, which is the professional certified certificate for testers. I mean, it doesn't get you the job, but it enhances your CV. So what I've only done is break it down into smaller chunks so that it doesn't look too declarative. I was trying to bring it to, yeah, go for it, Rexford.
Yeah, so I don't know if anyone has got any other question. If not, we can just ask a few questions and round about. It's 11. I know some of you guys will be going to work tomorrow, so yeah, it's been a long class. Anyone or any question? If not, we just ask you guys a few
Yeah,
questions.
Omi, go for it.
I was going to ask, please, do we have materials available to read up, please?
Say that again.
Materials on this lecture you just gave to us available so we can read through it.
You have the video, do your research. Then there's I will see if I can forward it onto the guild. I'm not on the guild, am I? It's Rexford on the key. I'm on the QA guild. Okay, yeah. I will put one of the, what's that book? ISTQB Foundation. So you can either get a hard copy or the electronic copy. You can get it cheaper on eBay. It's as good as new. Yeah, or you can use the internet.
Okay, thank you.
Yeah. Okay, Rexford, let's throw 1 or 2 questions, and then just to know that I hope everyone is not lost. Revert back to the video. You definitely find it very informative. Like David said, I hope it's not too long. I was given 2 hours and I didn't complete it. I did 1 hour. Remember, we didn't even start early. We started 15 past. So, and I stopped at 45. So that's the only thing I did was giving you a lot of breakdown. So maybe that's what I won't do next time. I will make it a bit declarative.
Rita, don't let my comment bother you a
No,
lot.
no. I
Yeah,
get you because I had 45
just,
slides. Maybe
it's
that's
just,
why.
yeah, don't let my comment bother you a lot. It's just a
Right.
kind of suggestion, and
Yeah. I get you.
if it
So,
doesn't go, yeah, we're all fine.
okay, that's fine. Okay, rest for shoot, please.
So please, where can we get the recorded video, please?
It will be posted on the Davis is in charge of that, right? So Davis will sort it out. It will be posted on the QA Guild.
Yeah, so guys, during the class, Rita mentioned SDLC. So who can tell us what SDLC stands for? What's the acronym for SDLC?
Software development life cycle.
Life cycle.
Okay. And so what is software development life cycle then?
Software development life cycle talks about the stages of software development, the processes. It goes through from stage 1 to up until the final stage.
Okay. Is that David? Yeah.
Yes.
Okay, David. Okay, thank you. I don't want to hear you talk again. I don't want you to answer all the questions. So guys, David has defined what software development life cycle is. He says it's got is the stages. So can any of you on the call name, not even accordingly, but can you guys name the stages involved in software development life cycle?
Yeah, so we got requirement
Planning.
analysis. We
Okay.
got high-level design, low-level design, and coding, which is the build phase, I think.
So we've got like 7 or 6, 7, yeah. And you mentioned planning and analysis. Okay, I think, yeah. But the high level and the low level you mentioned is not in the software development life cycle. I mean, we have 6 or 7 main ones. I want you to mention those ones.
I think we have planning analysis, define requirement, testing, and some other ones. I think maintenance.
Okay, you've mentioned 4.
We
Okay,
have
so
design, we have development, we have testing, we have deployment and maintenance.
wow, you guys were very attentive.
Well done.
Are you taking names, Madam Rita?
Yes, I am. And
Okay.
some of you are mixing it up. SDLC had 7, which Omi mentioned, I think 4. The guy that talked last, you kind of mixed it up with SDLC, define requirement. It's not on SDLC. But it's fine. Like as I
No, we
said,
have.
please always take note. Go on, Resford. You want to say something?
No, it's fine. It's fine. So okay, you guys have mentioned these things, like all of you have mentioned, but who can mention it in order from planning to maintenance? Who can mention these steps in order?
Can
I go?
Yeah, go for it.
Can I go? Can I go? I think planning and analysis. Plan analysis. Define requirement. Development.
No,
development.
you missed one out.
All right. I will go.
We have
Planning, analysis, design,
development,
implementation, testing,
deployment,
deployment,
maintenance.
and maintenance.
Oh.
Can I give it a try?
Yeah, of course, as long as, yeah, give it a try, yeah.
Planning and analysis, define requirements, design, development, testing, deployment, and maintenance.
Wow, wow.
Well done, Ome. Yeah, I kind of confused you guys when I said define requirement is not there, isn't it? Yeah.
Yeah, exactly,
Well,
exactly.
yeah. Well done. Well done, well done. I mean, Temitope, your hand is up.
Yeah, I want to try.
Okay, go ahead.
So, planning, gathering requirements, design, implementation,
I
test.
didn't use the word implementation, so obviously you are checking it on.
I have a note, like a PDF file on it already
Okay,
myself.
okay,
What
but
is
that's good. Yes, implementation. Yeah, it can be interused. Yeah.
implementation, deployment, and maintenance.
Well done. Okay, so I just want one person now. You guys on this same SDLC, and if you remember the analogy I used, so for me to know that you guys understand this SDLC and in the way it should be structured, can somebody explain it using the analogy that I used? Who wants to do that? Step by step, using the analogy. That means you have a good understanding of the SDLC. But this time around, I want you to use the analogy. Come on, guys. That would have been an easier way to understand it.
I think it had to do with cooking or something.
No, now you missed it. For the
Really?
SDLC, I used the house building. It was SDLC, I used cooking.
I think you mentioned about talked about fixing a door in a bathroom or something, and then the carpenter.
No, from the beginning. I want it from the beginning.
Okay.
So using a house analogy.
So,
building a house.
using the analogy of the house building.
Yes.
So first, you obviously, using the planning, you have to have a set out plan of what you want the final outcome of the house to be, which is you doing an architectural planning or structural plan, all those. I don't know if I'm getting it right, but yes, that way. Then, okay, well, planning is when, okay, a very structured outcome of what you want to get, your desired outcome. So the other one, which is gathering requirements, which is requirements, what will be required in the process of building the house and all the whole requirement needed for it. Then design. In the analogy, let's say design comes to play with, let's put it with the architectural design, like, okay, this is where the staircase will be, this is where the car park will be, like just a design. Please let me know if I'm on the right path.
Yes, you are. Go on.
Okay, so the next step is coding or implementation. So which is, I'm sorry, I can't get you. I didn't get your exact word. Listen, but that part is where you start taking necessary steps, like, okay, putting bricks by brick towards making the building stand. Yeah, so, and the next one is testing. After we've done the job or in the process of doing the job, at the brick straight, is the measurement all right? Is everything, like, are things in the right place? Is it going according to what we planned in the first stage? Like,
Mm.
is it aligning with our end product? And
Requirement. Mm.
yeah, with our requirement.
Mm.
So deployment, can I skip that? I don't know how to put that in the analogy.
Well done. You did very well. So that
men-
would be, yeah. So I'm gonna stop you there. You've done so well.
Can you lift the ban from me?
Say that again.
Can you lift the ban off me? I was banned not to say it in again.
Yeah, that was Breastpod that gave you a ban. Yeah, yeah. You can speak. So our time is fast spent. We'll be touching on this next week. I want you guys to revert back on the video. Next week, not next week, Friday, we'll do defect, and it might not be that long. Then next week we will do test plan. That should be taken by Rexford, hopefully. But yeah, so I want you guys to have a good understanding of this. By next week, I will throw more questions. And remember, in the previous class I did the introduction, I talked about why it is important, why SDLC is important. Please visit that as well. Do your research, because it's going to help you. Like as I said, if you have a deep understanding of your manual testing, it will help you in automation. And trust me, with manual, you can get a job. So this is just the easiest part of testing. And it's way easy for you guys to get a grasp of. So we'll end the class now. And then we'll meet again on Friday, God willing. Yeah. So have a good night, everyone. Please revert back on the video. You guys should chase up Davis. I don't know if he's allow me or Davis. I think allow me will be the one to. Yeah. So good night.
Thank you.
Good night.
Thank
Bye.
you.
Thank you so much. Thank you, Nathan. Thank you, everyone.